I finally got Ian Schmertzler on here from Dispel. Glad to have you, sir. Welcome to the Subnet Summit. This is going to be exciting for the crypto folks because most crypto folks don't know security or moving target defense and what that means for the general security industry. So I'm super happy to have you here, and I'd love to dive into the work that you guys have done that you're allowed to talk about, and what you can share with us, and what you'd like us to learn about what we can do with Dispel Secure Enclaves. So, welcome, sir.
Thank you, sir. It's
Yes.
good to be here.
Yes.
All right. How you want me to do this?
All
you
right.
Want me to
So,
be
why don't we just give me an overview of the company? Like, I know there are going to be people who don't know you at all because you're not on Twitter, and if you're not on Twitter, then you're not even in crypto. So, why don't I give them a reasonable introduction to you, which is that you and your brother co-founded Dispel in 2014.
Yeah, that's right.
Yeah, co-founded it in 2014. You guys bootstrapped users. You basically didn't raise more than like maybe a seed round, and then you're like serving mainstream like municipality water systems now and securing the networks for like Fortune 500 companies. So good on you, sir.
Thank you. Okay. This, if I've done this right, this is an unpitch. It's a non-pitch. It's something that people can do themselves. We do what I'm going to talk about, but I know you guys. You're going to just do this yourself, anyways, regardless of what the patents are worth, anyhow. So
this is YouTube. This is YouTube,
this
sir.
Is YouTube. Yeah, we'll do our best.
Okay.
But
okay.
At a minimum, you'll understand these concepts. You've got the deck showing, right?
Yes, sir. It's
Yeah. All right. I'm going to use this. Just interrupt me halfway through, okay? But what I'm trying to explain here is the concept of, one, what is a moving target defense system? And two, what do you do with it in the space of crypto, or more specifically, contracts/subnets? So the problem set here, let's start with some definitions, is it's the same one we've all faced since we were kids, throwing clods of dirt or snowballs at one another. So team one is a dodgeball team that is stationary for only those periods of time where you see a band of color. Team two is stationary all the time. They've just got lunch trays in front of them. Now, which team do you want to be a part of more? I will grant you, if you're kind of winded or tired or bored, you might just take it to the face and be part of team two. But most of the time, you'd prefer to be part of team one, which is totally. You're stationary, you throw an object, and then you get on the move again. This is a strategy, and it's known as shoot and scoop, which is you shoot, then you move. And it's also known as moving target defense. So for lack of an alternative, for the first 2/3 of cybersecurity as a profession, if one looks at the history, people were implementing something known as static defense. You built a castle, and as time and money allowed, you would add additional walls or improve the ones you already had. Now, this technique also, excuse me, is applied to communications. So you got a communication going between point A and point B. You got to defend it somehow. The only way people saw to defend it was to harden the endpoints that were communicating and then encrypt the traffic between A and B. The alternative to all of this is a technique known as moving target defense, which is you take what you care about, put it in a vehicle, and you move it around. Ideally in a battle space, in a medium that's large enough that it's very difficult for an adversary to find you, much less follow you. So that's moving target defense.
Cool.
If I've done anything today effectively, you've got static defenses, castles, moving target defense, or submarines. Alternatively, shoot and scoop. So far, so good?
So good.
So far, so good. Okay. So the goal here for anyone in the community is preserve, in brief summary, it's preserve optionality in an unblinking environment. That's what you're trying to do. Why do you need cybersecurity? It's to preserve optionality in an unblinking environment. Why do you need moving target defense? Because you're trying to preserve long-term optionality in an unblinking environment. And what that means is, if anyone who's watching this who is worth their salt knows full well that if you are really good at playing the staring game, and or you've got some patience and some money, you know that if you record everything and you wait long enough and you're able to do some correlation work so you can hone down what it is you really need to work as a problem, eventually you're going to have economical means of finding the period of a modular exponential function. And then all those idiots out there who were using elliptical curves for long duration value stuff are going to find themselves in a bit of a problem space. So that leads you to the next thing, which is when you're instantiating something of value, what are you really doing? So it's also known as the candy store problem. And this one is one that you'll hear people in cybersecurity referring to all over the place. So what is the candy store problem? There's a candy store. In this case, it's the instantiation of a subnet. But if you want to find the candy store, or you want to find a participant in the instantiation of a subnet, what do? All you have to do if it's a candy store is you have to find all the kids in the town, or find one of the kids in the town, because you know that they will eventually go to the store which has the candy. So you follow the kids around, or you find one kid and you follow them to the candy store, and then you're able to watch at the candy store until you see all the other kids going there. If you're in an unblinking environment, in other words, a world where someone is observing and collecting data, well, this is a problem of just data analysis over time. So your goal to solving the candy store problem is finding a means of effectively disassociating the kids from the candy store. And it's not like you're trying to do this for all of time. Yes, if someone has a perfect computer and the benefit of all the energy in the universe, they're eventually going to find just about anything if they want to. But what you are trying to do is make it hard enough that within any reasonable, usable time frame, that's not going to happen. So what you end up doing is you end up creating these disintermediating components between the kids and the candy store.
Okay.
So far, so good?
Yeah. So in this case, we're talking you want to move the RPC nodes that serve the subnets.
Yeah, you either want to do that, or let's, in any one of these situations where you're touching a subnet in any way, shape, or form, or you're preparing to spin up one of these things, you'll find people, it's the same problem set that you find in development of code these days for other settings. People are going to try and disassociate themselves from the thing of value.
Got it.
Cool. So with that in mind, how do you get that done? What I've tried to do here is lay out how to do this in a history. So anyone who can spin up cloud servers, can handle themselves with a proxy provider, is going to be able to follow this path and see that other people have been in their footsteps before. So how do you get this done? We have A and we have B. And in an abstract layer, let's pretend that A is a human and B is a human, and they want to talk to one another. They need to work on something. Okay, it used to be the case that A and B were talking to one another, and you needed to encrypt that traffic. Now what we're saying is we're going to disintermediate A and B. That doesn't mean we're going to change how the encryption is done, but we are going to disintermediate the two of them. What you initially would do is you'd spin up something between A and B. If you weren't spinning it up, you were buying some piece of hardware and parking it somewhere. So it would look like A was talking to that object and B was then also talking to that object. Well, over time, what you would want to do is destroy that thing and replace it with a new one. Now, if you're in an unblinking environment and you have data that will have value over a long period of time, well, you're going to need to find a way to make it difficult for someone to identify this data stream as being of importance and then sieve it out from everything else. So that leads you to start asking sensible questions like, what if I were an attacker, who else could be using these things? So it used to be, for example, when you're dealing with industrial controls, people would buy an on-premises thing that would virtualize a server there. So whenever someone wanted to get into a piece of equipment, they would always go to a virtual desktop, which was stood up at the factory. And everyone thought they were doing the right thing because they were following the standards, because you were supposed to have an intermediate component that was disposable. But every attacker just looked at that and said, right, so all I need to do is find a way to identify these virtualization environments that are on these sites and then attack those instead of the disposable components that they're spinning up. So for people like you who are launching these subnets, you don't have the luxury of being a factory who can survive a hit. Your subnet is everything. So you have to do this right from the beginning. What happened historically was people said, okay, fine. I know that you can figure out who, I can't just be using something that's clearly my own that people are going to. So what I'm going to do is I'm going to start launching this across, I'm going to span several different disintermediating joints. And then I'm going to start using some shared space that's used by friendlies or people I don't know. You have Tor happening in the background. What this did was then lead to the question of, okay, if I'm an attacker, who owns these intermediate components? So people were being cheap, and they thought what they were doing was they were sharing information with complete strangers and therefore disassociating themselves from the thing that they were transiting through. But in fact, what was happening was bad people were simply spinning up the intermediate components and making them available for everyone, so they were getting the traffic, which led people to the next stage of this, which was they needed custody of the entire communications chain, but they needed to be operating in a battle space, which shortly thereafter would be used by someone else, which leads you to the use of public clouds in these environments. So why would you use a public cloud if, let's say, you're speaking to a colleague who isn't technically very savvy? You can have the best submarine in the world, but if you put it in a pond, someone's going to be able to find it. So you need to have custody over this chain of disintermediating components. So that means you need virtual machines launched on public cloud providers, launched somewhere. And you use public cloud providers because everyone else is going to be using the same space at some point in time. So this is what the world started to look like. And over time, it just got more complex. So A would be talking to a cloud server. Someone had spun that up. And then B would be talking to that cloud server too. Well, then came the risk that if you were just in one cloud server, that just wasn't enough. So people started to span different data centers, different cloud providers. And by the late 2010s, you found that people were doing all sorts of fancy stuff. They were splitting the traffic, and it all settled down to this sort of a layout where the first components on the edge weren't even necessarily cloud servers. They could be IoT, they could be proxy servers, but it came to be something where you were making yourself look like ordinary traffic in whatever part of the world you were in. And as to the middle, you had to have the capacity to span at least 3 different commercial public cloud providers. Now, all of this, I would note, can be done by hand. It just takes time. So companies like Dispel exist because there are real buyers who need this all over the place. And the result is that they aren't going to be spending time on humans to get this done. They're going to have someone automate it for them. And Dispel is one such company that worked on automating the launch and sustainment of moving target defense systems. So that, in a nutshell, is what people were looking at from an MTD point of view. And you'll find this within the cybersecurity standards. So NIST 800-160 Volume 2, which is the baseline cyber resilience standard in the United States, 853, which is the granddaddy for most of the people on this chat, and then 800-207, which is zero trust, is most easily implemented if you're using a moving target defense system. And then there's 800-172, which, despite the title, should you decide to look up this inane one, you'll find when you're reading it, it's about how to secure communications when you've got third parties coming into a data environment. And the application here is clearly different, but the solution set that they provide is prescriptive. And that's pretty useful if you're just trying to do something else and you need someone to be giving you some instructions on what the heck it is you're supposed to be doing. All of this stuff had an impact in other markets. What companies like ours found was we've always been looking at the cryptocurrency world a little bit askance. It's a community that, unless you know the people at the bottom of it, no one trusts. If you're trying to make your fortunes, as we are, in things like securing the means of remotely accessing 30% of the baked goods in Africa, just to pull a random one out, you're not going to want to disrupt that by accidentally securing something that might be used by nefarious individuals. However, there are good people in the cryptocurrency world. And there's also the problem of, if at the end of the day, something that starts out as a harebrained idea turns successful, but because someone in an inexpensive fashion was able to record everything that took place, even though it's in an encrypted state, from inception, unless you can find a way to make it so that when someone says, oh, XYZ company turned out to be doing something really cool 3 years ago is when they started, I'm going to rewind the tape and look for it. Unless you can find a way to make it very difficult, if not computationally impossible, for them to find that moment 3 years ago, you're going to have a risk that can play out pretty badly for you. So how do we do this? What this looks like, let's say we had 4 people who all need to work on the launching of a contract. What you're going to need to do, sorry, it's not animating. What you need to do, and PowerPoint has cursed me now, is each one of these components is going to need to pass through their own disassociated chain of both virtual machines spun up on cloud providers, proxy servers extended out into those particular regions, and potentially even an IoT device in that zone, to get up to this collaborative environment in the center, which are referred to as enclaves. You'll find that within the standards that were discussed earlier. But these paths need to exist for the moment when they're doing the instantiation. And after that, you need to be able to tear down these paths, change them out if you want to carry on editing things. But that's what you're going to have to do. And that doesn't require any given company. It can be done with a little bit of grunt work, but that is what you need to do if you want to implement moving target defense around contract instantiation. There, I did it with diagrams.
All right.
Until the last one, it worked fine.
Okay, so where do you see the serious weak point in, like, is it in RPC protection that you think Dispel could help? Is it at some other position?
There are 2 places that I see it. Well, actually, the easy one is not this. The easy one is people get lazy and they start talking to one another around one of these things. And that's where someone's going to find the keys, usually, to the kingdom, the proverbial kingdom. So securing a messaging.
The key in this place is the key to the validator. What's the piece at risk here?
Oh, I beg your pardon. No. So the validator, the initial piece is, of course, of value. But let's say the thing,
you mean
the
chain, Genesis file?
The Genesis itself is of value, yes. But the far more valuable piece is this thing starts to work, all the transactional activity around it, such as, hey, this is great, it's working, I have the following idea I'm going to apply to it, or I'm interacting with the following 3 counterparties on this thing. It's the chatter. The chatter becomes more valuable over time than that initial piece, unless God comes in and goes after that. So what can Dispel do as well? Provide a secure messaging service. It's basically moving target defense, wrapping a chat server. But find a way to encapsulate this stuff in a hidden environment so that people can collaborate over time in a secured place.
So do you mean wrapping like a secure Discord server or a secure Twitter server? What's the server that you want to wrap?
I can't give a company name because that would be improper in this sort of a setting, but a chat server would be a good one.
Okay, so chat server. So I'm not even sure you can wrap a Discord server. You can't. I'm not sure they even allow that. Maybe Matrix does. The open source Matrix does.
The one to wrap is Mattermost.
Yeah,
that's an easy one.
Yeah, that's a good one. Yeah.
That would be the one that I would do.
The
So go ahead.
so if discords are uh, a weak point, why don't we see these hacks? I mean, most crypto companies are just run in discords. So what is it about? Why do you think we haven't seen those type of hacks played out?
I don't have a good answer for you. Just isn't one right now. It's in terms of what I was looking. If I look at this problem space and see, okay, where's it going to get really bad in the next 2 years, 3 years? That's the one I see being the most vulnerable. But as to why something doesn't happen right now, it's the classic problem of you can't fix stupid.
Mm.
So if someone's doing something that's not a good idea, but they keep doing it because no one else has gotten nailed yet, they'll keep doing it.
So the risk here is, let's say you get all the chatter, right? I think you can just go into a Discord server and just download all the chatter. So you download the chatter, and then what's the next attack point after that?
It depends on what's been placed in the chatter, of course. But let's say, so the real value in an idea, like, let's take any business idea, which is, I'm going to do business with this soda company. I'm going to collaborate with them on the following thing. They've priced themselves at X for us to contribute in the following fashion. It's the trade data that I would think is going to be the most valuable. It's the planning data, in other words. So if I'm an adversary and I want to find out a way to get in front of something, the place you go is you go after the chatter.
Okay, got it. Would you imagine this also to take place in key generation somewhere? I think the key generation part has mostly been taken care of. There was that whole, the zero knowledge proof early private key generation. That's specifically for most people. That's not something they do. They don't do the ceremony of proving that the first Genesis key is secure. That's generally not what people are doing these days. Although ZK Sync may be into that, but let's say you secure chatter. What's next? Like, are you talking securing RPC nodes? What's next up on the table?
All right. So the other thing you were quietly just mentioning, yes, of course, that is important. it's very important. Most people just ignore it because they don't think anyone's watching, because they don't think that they're relevant yet. And there's some good reason to think that the world hasn't thought most of this stuff is relevant. But the initial key generation, of course, that's important. And of course, you want to keep where that happened secured from prying eyes, not just now, but into the future if they try and wind the clock back.
Interesting. Got it. Do you it's an interesting question around Mattermost for me is the Discord servers are so natural for the crypto community. It'll be some sort of other learning curve to get people involved. So for someone like Landslide, who's just kind of starting, like we just released our open source, we just open source a ton of software yesterday, and we're gonna start an incentivized testnet. It's probably best for us to get our users used to a more secure chatterbox. Although that might bring down our ability to bootstrap users.
That's the problem. That is the puzzle. So a little bit of history about Dispel. No harm, no foul on talking about that. We tried to create a broadly available moving target defense encapsulated chat system 7 or 8 years ago, or rather we tried to offer it. And what we found was outside of enterprises, it really didn't take. So the question then was why? And I think the answer is the one that you were just, it's a matter of whether or not you get a network effect. People are used to a particular platform. They don't want to move on to the other one. They'll move to another one if some tectonic event happens that forces them to scurry over there. But until then, there's this perception that if you've got encrypted traffic, you start to let your guard down. You forget that everyone that you're communicating with might not necessarily be a friendly. You start to become boastful. perhaps using a relatively recent thing, someone posts some photos they shouldn't be in a community channel. But the same thing is true if you look at the encrypted comms. In other words, if you aren't able to pierce the encryption, let's say A is talking to B, but you are able to view the traffic, you can start to develop patterns. So you don't necessarily need to know the content of a communication to understand the intent of the communicating parties, which leads one to the next thing of, okay, fine. If we accept as true that there is a benefit to encapsulating a chat system in a moving target defense environment, what's it going to take to get the community to shift over to it? And that's a question, if someone finds the answer to, I'd love to know.
What's it going to take for a community to stop using Discord and use a secure?
Well, unless Discord, of course, puts itself inside a moving target defense segmented networks, which is entirely within their capacity to do. Unless they start changing, that's the right question. Is when are you going to see a shift over to a zero trust, misattributable networking topology for comms associated with these different communities?
With a giant collapse, like a giant bomb would basically, like another version of Terra would have to explode, and even then, I don't suspect that would shift people over.
It would be very interesting. Something very, very profound would need to happen, which is, I think, why this market has been one which a lot of my peers at other firms have also steered somewhat clear of / stared askance at, waiting. So the scuttlebutt here is that everyone's been watching, waiting for that moment to happen from our side of the world. And it hasn't yet, but we just think it will eventually. So that's that.
Can you unwind people's keys from their chatter?
You don't need to most of the time. What you need to do. So this is with cybersecurity. The problem is not necessarily I'm going to have a powerful computer that's going to break everything. Oh God, they had that. No, what you need to do is you need to find the weakest human within the links and find the weak point there, and then you start your work your way backward. So that's why disassociation becomes so important. Or if you just want to look at a standard NIST 800-207, zero trust. Yeah.
Yeah, interesting. There are, so I'm still struggling to understand it, because it's so obvious that it's sort of a honeypot, but everyone's kind of using Discord anyway.
It's a marvelous application. I mean, no criticism to Discord whatsoever here. So,
but the issue is what people can do with the chatter.
Right. You've created everything around these currencies depend upon accelerating interaction. Therefore, you are drawn towards things that accelerate comms between people. So you have the exact thing you don't want taking place at the same time. So there are ways to solve it. A combination of zero trust and misattribution are the ways you do it, and at a theoretical level. Right now, the only piece of the puzzle that seems to be missing is the economic moment where people say, fine, I'll pay for the solutions. What is heartening is there is strong demand in more established markets for these things. So what I don't think is, it used to be the case that no one could buy this damn stuff, so they were all building it themselves. That's no longer a problem. When 2,000 some odd farms in America run their irrigation through moving target defense networks, it's not the sort of thing where you need to go very far to buy it. So my guess is when this thing toggles over, it will be one of these things where the hand just turns. That will be that.
So the farms running this, the farms are running like a Mattermost for the farmers to talk to one another inside.
I beg your pardon. No. The networks are moving target defense based. So in other words, the basic infrastructure that you previously had to be quite independently thinking of, how am I going to get this? How am I going to build this? That already exists. parking a Mattermost server inside of a moving target defense environment and appropriately stringing it up, that's one additional step for people. So it could be offered as a SaaS service. It could also just be offered as be done in a home rolled way.
Got it. Well, maybe the economic drive factor for us is that we can drive people to the secure chatterbox with incentives.
I would think that could do it. Yeah.
It might not be sticky long term to send people that way, but we don't know. The other thing that you've told me sort of offline is that these, which is kind of taking a right turn here, is the encryption algorithms that you're worried about. Most of the encryption algorithms that are used here, you feel are already compromised. Some, it's like the future is here, just unevenly distributed. So you've said to me that we should switch into a quantum encryption algorithm out of the box.
Yes.
So
You have this.
So if that's the case, then why do no major cryptocurrencies actually use this particular NIST crystal lattice algorithm?
Crystal Kyber?
Crystal Kyber.
So I don't know. That's part of why you find this. There are brilliant people doing cryptocurrencies, and then the people who are doing secure comms in defense or in critical infrastructure, the two shall not meet for some reason. But if you're sitting there staring at the relative tempo of advancements in quantum computing, and you have any respect at all for what those things can do, the idea that people are still using Curve 25519 for comms that have long duration values, in other words, I'm not just saying I'm going down to the shop tomorrow and that's when the value of that communication goes out the window. Instead, it's like, I'm communicating with you on details of how this thing is going to be structured. And if this stuff gets revealed within the next 10 years, well, the commercial value of this project is out the window. It's madness. The solutions are not only inexpensive, they are standardized. You can download them. You can read a manual. So what the heck people are doing it is a profound mistake in my personal view, and it's one that people should pay more attention to.
If we let's say if some of these subnets that are launching, we're talking to a bunch of them, but there are maybe a couple hundred in testnet. If they choose to swap their crypto libraries into the quantum resistant library, does it somehow break the communication between other systems? So
no, to me, I don't know. That's an engineering problem, which is outside of my normal domain. But if they are following the new CNSA guidelines, then they're doing the best the world has approached the problem of finding a solution to. But I'm not answering your question because I don't know.
Well, for us, we're building so IBC, inter-blockchain communication. It's this open source bridge that has been securing all of the Cosmos network, right? That if that cracked, there's very little that I think it would just stop. I think they built the system so that if a state actor attacked it somehow, the relayer between the two chains would just stop. It wouldn't. It would stop processing transactions until it was brought back online. But I think that IBC needs to be able to communicate to in like a post-quantum cryptography library. I think that's where that needs to go. And so if we turn that on and we're the target chain that people are moving assets from IBC, but from Cosmos to Avalanche, then we just have to make sure that the cryptography library is compliant.
I see what you're saying. Yeah, the handshake on the other end, they're going to have to understand it. Yeah, fine. But if they were able to do all the rest that was involved in wiring this thing up, they could sort that problem.
Okay.
That's not the hard part.
Okay, good. So then it's just a library issue. Okay, great. We'll just swap it out.
That's my advice.
Okay, we got a couple more minutes here. You also said that you guys are releasing a new product this month, specifically aimed at the crypto Web3 community. Do you want to go through that a little?
Sure. So, and most of what we're doing is we're making available to the people, the friendlies that we know, a means of getting. If they want to spin up a new contract, we'll do this less than as a one-off, so people can have that. And further, if they do want to secure the comms around one of these things, then we can offer them a segmented environment within which they can do those communications in two formats, one being file transfer and the other being chat. This is very much if we think you're squirrely, we're not going to do it for you. We're testing the waters, but it's also it's our effort to try and dip our toe into this world and see whether or not there's a real market for it.
Understood.
Yeah.
Okay, good. So if
That's
you're
it.
squirrely, you'll be sussed out. Right on.
Yeah.
So good.
If you happen to be named Nathan Windsor, you won't be.
You will not be squirrely.
Right.
Okay, cool. So any other closing thoughts you'd like to leave folks with?
No, you raised the one that I was trying to dance around, but yeah, other than that, no. I think I've accomplished my task of trying to teach people a little bit about moving target defense. I suppose the only other thing,
I do have an addition, which is smart contract deployment.
Yes.
So when we deployed some smart contracts for a real world asset marketplace, we developed a marketplace called Liquid Earth. And we deployed it on. We deployed the contracts on Phantom mainnet, and we used a burnable virtual machine to do that. Let me ask, why do you think that was an important choice for us to do versus what you see normally, which is just someone logging into Hard Hat and just deploying it on terminal?
It's that one, what you did was the right thing to do. There's just objectively no reason why you shouldn't do it that way. Two, it's a pittance to do it that way versus the other way. Why specifically do it on a virtual machine and do it on one that's fresh? It's preventing something called dwell time. So if an adversary has gone in, dwell time, someone's gotten in, if you write a bot, it pokes around, it puts little observers all over the world. It's just checking to see what's going on. So you'll get certain things like the random state. and then it'll just be preserving this data, and it might be passing it back by one means or another. But it's just what you're doing there is a basic form of hygiene. You're preventing yourself from having those sorts of problems rear their heads, because instead what you're doing is, well, in your case, you were spinning it up in a very public, in a broad battle space where that VM could have been used by take your pick of other consumer or virtual machines at any given point in time. So it wasn't the case where someone was going to be readily able to say, aha, that I'll just go over there and check. So you have a fresh state, you have a fresh machine, and moreover, it was probably on a pretty freshly powered up environment underneath it. That's why.
Okay, so isn't this sort of another product offering of Dispel, like for non-squirrely weirdos?
Yes. Yes, it is.
Okay, so this is a really simple way to deploy a smart contract in a clean room versus your particular laptop with all of your observers on it.
Yeah. So context for all the viewers here. What Nathan did was he kept banging on the door because we happen to work within the same building, and saying that what we were doing was something that he wanted to use for his workstations, his secure workstations and work environments. And there's a certain moment where if someone keeps saying they want to give you money to buy something, maybe just maybe that's a product.
Maybe.
So this maybe. So what this is we refer to them as secure enclaves. It's the same thing that the terminology around 800.172 uses. So if you happen to be a defense contractor, of which there are 40 some odd thousand suppliers who are subject to this, there are two standards, 800.171 and 172 around data handling. And data handling includes you need a work environment in which you're going to handle stuff. These work environments, which are embedded inside of moving target defense rings, these are enclaves. So the only thing that happened here that was a bit different was you created an enclave to launch something, and then you pull down the exterior of that enclave, and you still had this thing that was out there in the cyber domain, which is wicked cool. So yeah, that's something that we offer. Yes.
Okay, so for people who want to deploy either smart contracts or subnets, they can contact you as long as they're not squirrely.
Yes.
Okay, cool. That is I'm a user. I've done it. I think it's well worth the time. Just to reiterate what it is, you pay a certain amount of money, which was very reasonable, to spin up a secure VM, a secure Windows machine that I basically logged into. I was able to I installed all of the necessary software packages, all the NPM, everything that we needed to deploy, and then deployed it. I logged in. I created a new MetaMask to deploy the actual smart contracts, and then I just made sure that there was no money still left on that MetaMask. So I created the MetaMask on that computer. So like the level of paranoia was sort of extreme here, even though we didn't, end up really deploying any capital to that contract yet. That contract's still up, that it's still functioning, but we just haven't pushed anything through it. But yeah, I recommend that to people. I think it's really an underrated. I mean, it's a product that's basically missing from the space, a secure enclave to deploy. So I've been telling you guys that for years. I think it's a great product. One that I think most of the crypto community would buy. They'd probably, they're more likely to buy that than to switch from Discord. But so that's just my personal thought on
it. I didn't expect to get a toot for this on this thing, so thank you.
Yeah, I think that's great. So I'll links. We'll have links in the descriptions for people to reach out. And yeah,
Cheers,
I don't have any other questions. That was very helpful.
Thank you very much. Good luck with the rest of this.
Great.
Right.
Awesome, man. Well, thank you so much for your time. I appreciate it, Ian.
Thank you.